My name is Zulkifli, and today I'm going to present about Bachelor Degree Project 1. My title is Comparative Studies of TUNG and LINSEED Oil Microcapsule as Self-Healing Coating for Corrosion Protection of Low Carbon Steel Substrates. My supervisor is Madam Nur AIMAN HANIS bin HASIM from Ftkmp, and my co-supervisor is TS Dr. Muhammad FAUZI bin MAMAT from GTI. So for the outline presentation for this presentation is first we have our introduction, then we go to the literature review, and then this is methodology, expected result, and the last one is the reference. For the first one is the introduction. Nowadays, metal corrosion is slowly becoming a focal point of worldwide industrial development. It has a potential to cause the collapse of the buildings, bridges, the rupture of oil pipelines, the leakage of chemical facilities, and the flooding of toilet. Corroded electrical contact can create fires and other issues. And for the problem statement in this project 1, metal corrosion is primarily caused by the two factors, which is material and its surrounding. So the corrosion occurs when the coating barrier of the low carbon steel surface is mechanically eroded as a result of the surface microcrack or scratch. So when the damage occurs, the corrosive species will penetrate to the low carbon steel substrate surface, necessitating the use of the coating with the ability to self-heal in order for the damage to be automatically repaired. And the ability to self-heal may aid in the prevention of the corrosion. Main objective for this study is to develop self-healing coating consists of TUNG and LINSEED oil, then to analyze the corrosion behavior of uncoated and coated low carbon steel substrate in the sodium chloride, then to investigate the effectiveness between TUNG oil and LINSEED oil as a self-healing agent. This study is to determine the best healing agent formulation, and then to cut the low carbon steel substrate using the laser cut machine, and then to do an emission test for the corrosion test, and then we coated the specimen with uncoated and uncoated epoxy coating and self-healing coating, and then we observe the corrosion for 35 days, and after the corrosion test we study the surface study using the SEM and NDX. Then for the literature review, carbon steel itself have 4 types. For the first one is a low carbon steel, which is the types that we use in this project. Next is the medium carbon steel, and then high carbon steel, and another one is the micro alloy steel. For the properties of a low carbon steel, it has a extremely low carbon content. It has less than 0.10% carbon and 0.4% manganese. The application of the low carbon steel, it is widely used in automobile body panels, tin plate, offshore pipeline, wire product, and all common application. The benefit of the low carbon steel is it is low cost. Low carbon steel is more bendable, which is it can improve its performance in some application while degrading it in others. Next is the literature review of the overview in the corrosion. So corrosion is the oxidation of a high energy process of metal or metal alloy. Different metal particle crystals such as generate voltaic cells. This can occur within a metal sheet or between two touching sheet, specimen 2015. Electrochemical transport of ions from anode to cathode causes the corrosion, releasing metal atoms that bonds with the oxygen. Is the form of corrosion. Corrosion can limit the service life of processing equipment in a variety of ways. This is some example of the corrosion. Number 1 is the uniform corrosion, crevice corrosion, stress corrosion, intergranular corrosion, pitting, and etc. Next is the corrosion control method. In order to control a corrosion, there is a 5 method, which is cathodic protection, material selection, design selection, barriers coating, and also corrosion inhibitors. What is a cathodic protection? Cathodic protection occur by increase the reaction rates in cathodic and decrease the reaction rates in anodic. This phenomena can be occur by providing a surface metallic area. This method can help to eliminate or reducing the corrosion. Next is for the selection material. Before we choose or select the material, we have to consider the elements of the corrosion. There is surface area, prospective environment, and also the material itself. Next, for the design selection. The design selection should be compute before we design the product. We should compute the mechanical properties and also the strength required to ensure the corrosion from occurs. So then for the barriers coating, we apply the coating such as a plastic, paint, and powder in the surface metal. For the corrosion inhibitors, there is two type of the corrosion inhibitors, which is organic and inorganic. So what is organic and inorganic? Organic corrosion inhibitors can be reactive, making them incompatible with a coating system, whereas the inorganic inhibitors can be reactive while also being very water soluble. Then the literature review for the self-healing coatings. So the idea of the self-healing coating is based on the repairing a damaged area with raw materials or component that heal quickly and store in inventory levels. Kana and France, 2016. In self-healing coating protection, two primary strategies have been pursued. One is amending of fall formed in the polymeric coating metric by adding polymerizable chemicals. Another one is suppression of corrosion occurs regions by using corrosion inhibitors. The literature review for the tung oil and linseed oil as a healing agent. The usage of this type of drying oil is because of the ability to react with oxygen in the air to form a new barrier film that protects the microcrack from the corrosions. Different properties of the tung oil and linseed oil is the tung oil is contain 18% of illustric acid, which have 3 conjugated double bonds, and the linseed oil has a cross link in the oxygen, which not more than 2 double bonds. Of previous study, linseed oil and tung oil. For example of the study of the tung oil is the Samadzadeh and colleague 2011 have conducted a study on the tung oil, 10% weight. They use a method that is in situ polymerization. The finding of this study is to examine the ability of encapsulated tung oil as a scratch healing agent for the self-healing coatings. Next, the example for the linseed oil is used by the B09191910153 and colleague 2017. They use amount of healing agent that is 5% of linseed oil. The method is same, in situ polymerizations, and the finding is to understand the healing performance of linseed oil as a healing agent using an impedance spectroscopy. Next, for the literature review for the epoxy coating as a metric. So, epoxy coating is known as a thermosetting metric for advanced composite with a good stiffness and specific strength. In other words, epichlorohydrin is a crucial component of epoxy, which it can create a strong covering that can survive at extreme cold, heat, and humidity. Then we go for the research methodology. This is the flowchart of the study. First, we have to prepare the specimen, where the specimen have been cut by using the laser cutting machines. in the diameter of 20 times 20 mm size and the 2 mm thickness. So before we go for the preparation of the self-healing coating, the specimen must undergo the mechanical test, which is a microstructure and hardness test. And after the microstructure and hardness test have been done, we study the surface by using the SAM and ADX machines. And then after the surface study have been done to the specimen, then we prepare for the self-healing coating. And after the preparation of the self-healing coating have been done, we go for the brush method apply on the substrates. And after that, we go for the emission test, which is we have three types of the observation, which is visual inspection, weight loss, and also corrosion rate measurement. And after the emission test, we study the surface by using the SAM and NDX. After the surface have been studied, we go for the result analysis and the report of the thesis. For the substrate preparation, we used to cut the low carbon steel specimen or substrate by using the laser cutting machine. And this, you can see the final specimen after being cut by the laser cutting machine. Next is the research methodology for preparation of self-healing microcapsule. First, we have 160 ml deionized water. We stir with the 5 gram urea at 700 rpm, and then we mix 0.5 gram ammonium chloride and 0.5 gram resorcinol and stir to 15 and 20 minutes. And then we add the emulsion of pH, adjusted 2 or 3 by adding 10% of hydrochloric acid. And then we add 2 or 3 drop of octanol. Then we mix all together in 15 minutes. Then we pour slowly 60 ml of linseed oil or tung oil to form an emulsion. Then we wait for the 50 minutes for the agitation. Then we add the 12.67 gram of formaldehyde. We stir them for 3 or 4 hours at 55 degrees at 700 rpm. Then we undergo the process of filtration. And then after the process of filtration, we wash the microcapsule using the acetone. And then we will have the linseed oil and tung oil microcapsule. We keep the tung oil and linseed oil microcapsule in the vacuum oven at 35 degrees for 2 days. And then we will have the final linseed oil, tung oil and microcapsule. Methodology for the mechanical testing, as I mentioned earlier, we have two process, which is hardness test and also microstructure study. For the hardness test, we use a Rockwell hardness test machine. And then for the microstructure study, first we have to use a grinding machine to polish the specimen to get the flat sample and smooth surface. And then we use the optical microscope to see the mechanical properties inside the specimen. Next, for the material characterizations. The material characterization we use to study the surface of the sample, which is the low carbon steel substrate. We use the scanning electron microscope, SAM machine, and also the energy dispersive X-ray analysis, which is ADX. And for the research methodology for the corrosion test immersion, here we have a sample of the immersion process. We have a container, and inside the container we have a low carbon steel substrate. Will be submerged in the 3.5% of sodium chloride. And then we observe the low carbon steel substrate for the total of duration 35 days. Then we use the equation to calculate the weight loss and the corrosion rate. The equation for the weight loss is the initial weight minus the weight after, and the equation for the corrosion rate is the kW per ATD, which is K stand for the constant, W is the weight loss, A is exposed specimen area, T is exposure times, and D is density. Then for the result expectation, self-healing coating have a high potential to be succeed based on the previous studies from the various researchers. Then for corrosion behavior, it will be shown that the coated material will have a high corrosion resistance compared to the uncoated material, and the uncoated material will have a high loss of mass compared to the coated material. And then for the comparison between the tung oil and linseed oil, tung oil is expected to have a more efficiency rather than linseed oil. And this is the Gantt chart for this PSN1. This is the Gantt chart for the PSM2. Is some reference of the journal that I use to refer for my PSN1. And that's all for me. Thank you.